So this video is Integrated 3, Semester 2, Final Countdown, number 1. This is the end. This is the last one. So on this first one, we are dealing with a difference of 2 cubes. Okay, let me write the formula. So we have an a cubed minus b cubed is equal to, and what we do is we take the cube root of the first term, which would be a, keep the sign, still minus, take the cube root of the back term, which is b. Then you're going to take your a and your b here. You're going to square your a, your first term, so you get an a squared. The sign is going to change. It was a minus, now it's a plus. Then you're going to multiply these two things together, which is an ab, ignoring the sign because you already decided on it. And then you're going to square the b, the negative b squared, which is going to become a positive b squared. Now, if this happened to have been a cubed plus b cubed, this would have been an a plus b. This would have been an a squared. And again, if that had been a plus, this switches to a minus. Multiply your a and b together, plus b squared. Now, this is a difference of two cubes up here. Okay, but what you always want to pay attention to before you get started, anytime you factor, you want to ask yourself, can you factor something out? So 64 is a cube and 8 is a cube. So they are cubes, but you can factor from both of them an 8. So first factor out an 8, because if you don't factor it out originally, you're going to have to factor out after the fact. It's easier to factor it out first. So you're going to have 8x cubed minus 1. Now, this is still a difference of 2 cubes. So I'm going to have an 8. The cube root of 8x cubed is 2x minus the cube root of 1 is 1. Now I am going to square this first term here. So that's going to give me a 4x squared. Since this is a minus because this was over here, this becomes the opposite. It becomes a plus. Multiply these together. Just the 2x and the 1. You already got your sign. So that's going to be a 2x. And then square your negative 1, which is going to be a positive 1. And that is your answer. If you did not factor out the 8 first, they are cubes. So you would have gotten your answer, but you would have had to factor further. So please factor out first. Okay, on 44. Okay, so this is an exponential problem. They are wanting us to rewrite it in log form. So we're going to go log base 3. So the base of your exponent is still the base of your log of 71 equals x minus 2. Your log always equals your exponent. Always, 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 always. And that's it. That's all they wanted. Okay, so now this one is kind of review from integrated 2. Factoring. So, well, we're going to solve this quadratic either by factoring, completing the square, or quadratic formula. Let's see what goes on here. I definitely probably am not going to choose completing the square with a 7 in front. But let's see what we get. 7x squared minus 2x minus 3 equals 0. So looking at this, just a quick little check. If I multiply these together and I get a negative 21, can I add anything, multiply anything that goes to negative 21 and add and get a negative 2? I cannot think of anything because it's a 21 and a 1 and a 7 and a 3. Neither of them are going to get me a 2. So not going to factor. You could do completing the square, but if you have a number in front, you're going to have to factor that out or divide that out. And that's not going to be pretty in this problem. So you're going to use quadratic formula. So quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where you do not decide what your a, b, and c are until it equals 0. So my a is going to be 7. My b is a negative 2, and my c is a negative 3. So now I'm going to put these values in to my formula. So I'm going to have x is equal to a negative b. Since my b was negative, negative b means make it opposite. So it's going to be a positive 2, plus or minus the square root of negative 2 squared. And anytime you square something, put it in parentheses. So you get the right number answer. Minus 4 times a, which is 7, and c, which is a negative 3. all over 2 times my a, which is 7. Okay, so I'm going to get 2 plus or minus the square root. And let me compute what's in the, sorry, just trying to make this a little bigger here. Get my select. Okay. So I'm just going to be doing what's underneath the radical. So I'm going to have -2 squared. And again, I want parentheses around it. I should be getting a +4. And if I don't put parentheses, it's going to give me a -4. So you want to be careful. -4 times 7 times a -3. And I end up with an 88. So this is an 88, which definitely shows me that it was not factorable because the square root of 88 is not nice. Now, we never want to leave it with a perfect square underneath my square root. So I know for sure a 4 goes into it. Okay, 4 goes into it 22 times. So 4 and a 22. Well, 22 would be a 2 and 11. And then I have my 4. The only square is this one. So I'm going to rewrite this 2 plus or minus. The square root of 4 is 2 root 22. Okay, so again, since this is a square root, I can take the square root of that, which is 2, and then my 2 and 11, which is my 22. I can't take anything out, that stays under. Okay, and then this is over 14. Now, everything here is divisible by 2, but you never, ever are going to do anything with what's underneath your radical. I'm looking at the number in front of my radical. So I'm looking at this 2. Whoops, hold on. Let me grab something to write with. I'm looking at this 2, and this 14 to see if I can take anything from all of them. If I can't, then that would be my answer. Okay, so I am going to get as my final answer, because 2 goes into 2 once, 2 goes into 2 once, so that's going to be a root 22, and 2 goes into 14 7 times. That's my answer. Okay, on number 46. Okay, we're going to try to simplify this. So let's see. First thing I'm going to do is probably change things into sines and cosines. So this tangent of x is going to be I'm going to write tangent. Tangent of x is going to be sine x over cosine x. And right now I'm going to keep my cosine squared x here. So that's going to be okay. I'm going to keep my sine x. And then I am going to rewrite this. The reciprocal of cosecant is sine. Remember, c doesn't go with c, s doesn't go with s. So this is going to be 1 over sine cubed x. So then when I'm looking at this, on top, I'm going to have a sine squared x, cosine squared x. On bottom, I'm going to have a cosine x and a sine cubed x. And let's see what we have. So I can clean this up. This and this, I'm going to end up with sine squared canceling from top and bottom. And I'm going to be left with a sine x on bottom. And when I'm dealing with this cosine squared x and this cosine x, a cosine x can get canceled out from both of them, and I will be left with a cosine x on top. And a cosine x over sine x is a cotangent x. And that's what that big old mess simplified to. Okay, 47. So on this one, we're going to fraction bust. So I'm going to multiply everything by 14. So I'm going to multiply everything here by 14. So I am going to have 14 times that minus x over 2 times 14 equals 5 times 14. So everything got multiplied by 14. And the reason I did that was because 7 goes into 14 twice. So that'll give me a 6. 2 goes into 14 7 times. So I'm going to get a negative 7x. And then 5 times 14 is going to be 70. So now I'm going to have a negative 7x is equal to a, subtracting 6 from both sides, so a 64. And then I'm going to divide by 64, and I'm going to get, sorry, divide 64 by 7, negative 7. I'm going to get negative 64 over 7 as my answer. On number 48, okay, so we want to do this from 0 to 2 pi, okay? So where is your sine? 0. Sine is your y, and sine is 0 here at 0 radians, and here at pi, and then again at 2 pi. So since they're including 2 pi, we're going to have 0, pi, and 2 pi as your answers. You're going to have three times from 0 to 2 pi. Okay, on 49. So when we're factoring this, we got a 2 sine x. We have a sine x. We have a negative 1. So one of them needs to be positive, one of them needs to be negative. I'm going to put the plus 1 here because that's going to multiply with this and get me a positive 2, and then negative 1 here. Okay, so now this particular factor is going to lead to, when I set equal to 0, I'm going to add 1 and divide by 2. So I'm going to try to figure out where sine x is 1/2. Sine is your y. We are looking from 0 to 2 pi. So I want long, short, basically. Long, short, but in the positive y. So this is going to be pi 6. It's also going to be over here because this is long, short. It's a positive short. So this is 5 pi 6. So I've got so far pi 6 and 5 pi 6. And then I'm going to set this one. And so this would be sine x equals negative 1. And your sine is negative 1 down here at 3 pi halves. At 3 pi halves. And this is your answer. On 50, factor the expressions and use the fundamental identities to simplify. So we want to simplify this. Now, what I notice is we have a tangent squared x that we can factor from both of them. So this is going to be a 1 minus sine squared x. And then this 1 minus sine squared x, this right here, I'm just going to write here the Pythagorean identity. Sine squared x plus cosine squared x equals 1. And so if I am going to rewrite this and subtract sine squared from both sides, I am going to end up with cosine squared x equals 1 minus sine squared x. So I am going to be putting this cosine squared x in place of this. So now I'm going to have tangent squared x times cosine squared x. And I am going to rewrite my tangent squared x at this point. So my tangent squared x is sine squared x over cosine squared x times cosine squared x. If you want to put it over 1, you can. And then I can cross out this cosine squared x and this cosine squared x. And this whole entire thing reduces to sine squared x. And that is our answer. And that's the end of our last video.